So x is 11.99, which is approximately 12. And that's the altitude. So we took an equilateral triangle, we knew what all the sides were. We cut it in half to make two right triangles. So then we divided the bottom in half, right? So now we have Pythagorean theorem. We figured out what this missing side was, and I rounded up.
What is you
11.99, or approximately. Because this one is before I square it. This is after. Remember, it's 8 square root 3 divided by 2. Because it's half of this. So we cut it in half. So 8 square root 3 divided by 2 is 6.9. And Jacob just asked that question. Yes? Okay, so we've got the altitude of an equilateral triangle is 6. What is the length of each side? Okay, so this is backwards. So we've got an equilateral triangle. All the sides are the same length. I know the altitude is 6. I want to know what everything else is. Okay? All the sides are the same, so I know, let's give the sides x. If we divide x in half, what do we get? X over 2? Or 1/2 x? Okay. So we're going to go x squared plus, oh, that's not true. We're going to go 6 squared plus x over 2 squared equals x squared. Okay, so we get 36 plus x squared over 4 equals x squared. We are going to do what now? Is there an easier way for me to do this? Hold on one second. What?
Wouldn't it make it 30, 60, 95?
It would. Which would make my life easier. Right, because this is 30, this is 60, it's a 90 triangle. So that's 6. So if we want to find out what x is, we know that is the hypotenuse. The longest, I'm not sure why we're still talking. Okay, so for a 30, 60, 90 triangle, if this is 30, this is the smallest side, this is x square root 3, and this is 2x. So we want to find out what 2x is. So we've got x square root 3 equal to 6, so we've got x equals 6 over the square root of 3. We're going to multiply the top and bottom by the square root of 3 because we can't have a square root on the bottom. So we get 6 square root 3 over 3, or 2 square root 3. That's the small side. We times it by 2 and we get 4 square root 3 seconds. Let me go over that one more time. It's a 30, 60, 90 triangle. We know that the smallest side times the square root of 3 equals the longest side, the second longest side. So that's what I'm doing here. Okay? We get that the smallest side is 2 square root 3. If you multiply that by 2, it gives you the hypotenuse, which is all the sides of your equilateral triangle. All right, that was number 10. 5 more to go, guys. Then I'll give you some time to work on in class if you have time. You times it by 2 because you want the hypotenuse. All right, now we're going to get into some trig. Okay. One of the reasons this review actually has more trig stuff on it than anything else is because trig was, one, the longest thing we did ago, right? So it's probably the least likely to remember it. And it was the poorest quiz for us. So that's why I'm spending more time on trig than anything else. Your test is pretty equal, divided between chapters 7, 8, 10, 11, and 12. Okay. We want to find the tan of 8. Tan is what? Remember what tan stands for. Opposite over adjacent. So we look at A. What's opposite A? What's adjacent? 7/24 is your answer. That's all you had to do. Let's look at 12. Okay, 12, we're going to start looking at chapter 8. What is the measure of each interior angle in a regular octagon? Yes? Okay. What is the measure of each interior angle of a regular octagon? How many sides does an octagon have? Do you guys remember this formula? N minus 2 times 180. But this says each interior angle, so we're going to divide it by what? Yeah, the number of sides, N. Okay? And I'm just giving you the general formula so that you can plug it in for whatever it is. So I'm going to do 8 minus 2, which is 6. Times that by 180. And then divide that by 8. 135 degrees is each individual angle. Okay, exterior is a little bit different. We've got a pentagon, so let's draw a picture. Okay, so here's a pentagon. We want to know the exterior angle, this out here. But I want to draw a picture so we know what we're talking about. Okay. Because I wanted to know each side. The n minus 100, n minus 2 times 180 gives you the sum of all the interior angles. If you divide it by how many angles there are, you can get each one. Okay, so what is the measure of the exterior angle in a regular pentagon? So exterior means outside of it. So we take 360, divide that by the number of sides. In this case, it would be 5, and we'll get 72 degrees. All right. Yeah, but why would you do all that? But totally can. Yeah. Okay, let's move on to 14. For the parallelogram, PQLM below, if PML, so PML, this is right here, it's 83 degrees. What is PQL? It would be 83 degrees or B. Okay, because opposite sides of a parallelogram are congruent. No. All right. Let's look at 15, and I'll let you work on the rest. Choose a statement that is not always true. For any parallelogram, the diagonals bisect each other. Opposite angles are congruent. The diagonals are perpendicular. Opposite sides are congruent. C. B. All right, ladies and gentlemen, you can go ahead and work on 16 through 30.